So this is a statics case study revolving around finding an equivalent force couple system. This is the Vlooyberg Tower in Belgium. It was constructed in 2015, and it was built to provide a unique platform to give visitors a view of the town and surrounding forest. It was designed by the Belgian engineering firm Close to Bone, and it actually replaces an old wooden lookout tower that was burned down. So the staircase and observation deck are supported by a structural steel frame covered in oxidizing weathered steel, which gives it an orange-reddish hue. The structure itself rises about 11.3 meters above the ground and weighs approximately 130 kilonewtons. The base of the tower is actually supported by two anchor points that prevent the structure from turning over, and that is the only source of support for the entire structure. So in this statics case study, we're going to look at determining the equivalent force couple applied at the support that prevents uplift, so the support towards the rear of the tower. We will then use this equivalent force couple system to determine the forces acting on both of the supports. So here I've made a simple model of the Vlooyberg Tower in SketchUp. We can see the average height of a person here at the base as well as at the top in order to show the scale of what we're dealing with. In order to solve this problem, we're going to have to make some assumptions, especially as it relates to the weight of the tower and the location that the weight is applied, so the center of mass, as well as the location of the reactions. So we're going to assume that the tower weighs 135 kilonewtons, and that's based mostly on the weight of the steel as well as the amount of steel that's used. We're going to assume that there are two reactions or two supports supporting the tower. So we have a pin at A and a roller at B. We don't really need to be concerned too much with what a pin and roller means in this problem specifically. Basically, a pin just can support a structure vertically as well as laterally, whereas a roller can only support a structure vertically. But really in this problem, we're only getting vertical supports from each reaction, so we don't really need to be concerned with that. So we also know that the weight is applied 8.6 meters away from A in the horizontal direction, as well as 4.7 meters above A and B in the vertical direction. So now that we know the loading, as well as the location of the loading, and these reactions, how they're 1.5 meters apart, the main point of this problem is we want to find the equivalent force couple system that this loading creates at A. So we want to take the force that we just saw in the location we just saw and replace it entirely with a force couple system at A using the strategies that we learned today in class. Once we do that, we want to actually go ahead and go from a force couple system and get rid of the couple and actually make it so that we know what the force is on each reaction. And we can do that by replacing the couple with a system of two forces based on the definition of a couple. So this is just a quick summary diagram showing the dimensions as well as the loading like we covered in this video, nothing new. You can pause here if you would like to try the problem yourself just to get a nice little summary of what we covered. And again, we want to find 1, the equivalent force couple system at A given this loading, and 2, the forces from the structure on A and B. And remember, a hint for number 2 is to use the result you get in number 1 as well as the definition of a couple to convert this force couple system to just two forces. And again, this case study comes from Beer Johnston, 12th edition. I did not come up with this. I just made the video showing a summary of the problem.